everyone, welcome back to the session. How are you all? I hope you all are good. You all are doing very well. So, what the thing, student, that in the last session we have started a new chapter, that is the mixtures and the pure substances. And in that, what we have seen, what are the elements and what are the type of elements, that is metals, non-metals, metalloids, and then we have discussed about the compounds. Exactly. So, students, we are going to cover up, or we are going to continue this session with the same chapter only, that is the mixture and the pure substances. So, like in the last session, we have discussed some of the topics. So now we are going to discuss some another part of this chapter. So the topics which we are going to cover up today is mixtures. Then what type of the mixtures are? If you remember that in the last session, I have shown you two type of the mixture. And if you remember that in one of the mixture, when the person is adding something, so it is going to be completely dissolved in the water. And after that, we are not able to find out that what the person has added in that exactly. But in the another one, the person was adding some kind of blue substance and it was not soluble in the water, or we can say that it is not dissolving in the water. So now students, we are going to find out that what type of mixture are. So we can see here that there are the two type of mixture: homogeneous mixture and heterogeneous mixture. And what are those? So we'll see that. Okay. Then we are going to discuss about the difference between the mixture and the compounds. Fine. So are you ready to start this session? Okay. So first of all, starting with the mixtures. So from the word only, like what is the mixture? So mixture is what? That when two or three substances mix up together, so we call it as a mixture. And everything, like if we see in our daily life, so whatever we are looking at, so they all are the mixture only. For example, student, if your mother cooking food and she is making some vegetable, fine. For example, if I take any example of vegetable, that she is cooking rajma, okay. So in that, what is required? Rajma is required. Then what you required? Water and other kind of spices like salt and red chili, and so many things are required to prepare for one vegetable. Exactly, student. So that's how we all mix up all these things, and that's how we are getting the mixture. So what we can say according to that, if we want to see a very general example, so the mixture is something when we add two or three type or more than also, like it's not limited to two or three or more than that also. So when we mix up all these together, so we call it as a mixture. So we can say that the mixture is something when two or three, or we can say more than that substances added together and we are able to separate them out by using any chemical or physical process. We'll see how. Okay, don't worry. So that are called as the mixture, student. Fine. Like by applying any chemical or the physical process, we can separate them out. But how? Yes, I know this thing that all of the mixtures can't be separated out. But yes, some of them are separable. And how we are going to separate them? So we'll see that thing also. So for example, student, as we have seen that, okay, the mixture is this. So if we take the example again, like if we take for a very simple example, which we observe in our daily life, where, like for example, the students or the children always like drinking cold drinks, or we can say juice. So what's the juice? So it is also a kind of mixture of water and the juice of the oranges or the any other fruit. Exactly. And in that, other additives are also added. So that's how it is also a kind of mixture. So everything is when the two or more than two substances mix up together and we are able to separate them out by using any chemical or the physical process, we call it as the mixture. Now what the thing is, student, that the mixture is divided into two parts. One is the homogeneous mixture and another one is the heterogeneous mixture. So students, if you observe the picture of the homogeneous and the heterogeneous, so in the homogeneous and the heterogeneous, what type of difference you can see here? That ma'am, by looking at the picture, I'm getting some difference. So what kind of difference you are able to see? See student, hetero and homo. So it's like that we can consider it one type of we can take one type of substance it is, and it is a second type of substance. And similarly in the homogeneous also, in homogeneous students, what you will observe that it is very uniform in nature. Exactly, that it is following some pattern, it is having some pattern, and you can see that first substance, then second, then first, then second, so it is following some uniformity. But if we talk about heterogeneous, so what we can see here, that in that condition, that the substances are not arranged according to the uniformity. We can see here that there is some kind of non-uniformity. Exactly, that the substances are present at very random position. So how they are present and how we are calling them as the homogeneous and heterogeneous, so we'll see in the next slide. Okay. So first of all, we are going to discuss about the homogeneous mixture. Okay, so what happened that, okay, we come to know that what are the mixtures, and we have seen some of the examples, and then we come to know, okay, mixture is something when two or three added substance add together, and after that we are able to separate them out. So we are calling them as mixture. But now if we talk about homogeneous mixture, that means we are talking about the types of mixture. So first of all, it is the homogeneous mixture. So homogeneous mixture is a type of the mixture, student, as you can see in the picture also, that it is a water, and the person is added a pinch of salt. Okay, or we can say a spoon of salt, and when he is stirring it, when he is mixing that salt, so after some time what you will observe, that when the salt is going to be complete soluble or complete dissolving in water, so you will be not able to find out whether the salt is added or any other thing has been added into the water. So such type of mixture, student, after mixing up all of the things, when you are not able to find out that what you have added in the water, so such type of mixtures are called as the homogeneous mixture. And that is why, student, in the homogeneous mixture, they always follow the uniformity. Uniformity, student, that means when that the salt is going to be soluble completely, and you will not find it out where the salt is. So that's how we can see that it is a kind of uniformity. Okay. Now, students, okay, this is the salt and water, that salt and water. But if we take the example of any other homogeneous mixture, for example, sugar solution. Okay, so again, student, in sugar solution, what's the condition is, you are having one glass of water is there. Okay, and in that, what you are adding sugar. And after dissolving the sugar, what happens? Sugar is going to be completely soluble in the water, and you will not come to know that whether the sugar is present or salt is present. Or we can take one example as well. Like there are two glasses of water, and in one I have added salt, and in another one I have added sugar. And now I am asking you this thing, that which glass is having salt and sugar. So you will say, ma'am, by looking at both of the glass, I am not able to find it out that whether it is the salt or sugar, because it is a kind of the homogeneous mixture. Why? Because after adding the salt and sugar, I am not able to differentiate between that whether it is the salt or it is the sugar, because it is completely soluble in water. So that's how, students, such mixture are called as the homogeneous mixture. So how you are coming to know that whether it is the salt mixture or the sugar mixture? By tasting it. Obviously, that when you taste the sugar solution, it will having a sweet taste, and if we talk about salt, so it is having a salty taste. Exactly. So that's how, student, we call them as the homogeneous mixture, when you can see that that if anything you are adding, so it is going to be completely soluble in the water. That's how we call it as the homogeneous mixture, and that is why it follows up the uniformity. Now, student, if I want to separate out the salt from the water or the sugar from the water, so will you be able to do that? By any process, as we have studied some process also. So do you know that which process we can apply here? So exactly, student, we can use the evaporation process. Evaporation, because in evaporation, student, what will happen? For example, this is one container. Okay, and in this container you are having water, and let's say it is having the salt solution. Fine, it is having the salt solution or salt mixture. That means water and the salt is present here. If you start heating it, so what happens, student? When the heating is there, so the water is going to be converted into the vapor form. Water is converting into the vapor form, and what you are left with? You are just left with the salt. So see, students, you are able to separate out these mixtures. So what we have read about the mixture is, that when two or three substances or more than that, when we mix them together and we are able to separate out those substances, we call them as the mixture. And first we have seen what are the homogeneous mixture, in which there is the uniformity. That means you are not able to find out whether the substance, that what type of substance you have added, if the color difference is not there. Exactly. So that's how, student, we have seen the homogeneous mixture. An example may be salt solution, sugar solution, or other examples can also be there for homogeneous one. And that's how, student, by using evaporation method you can separate them out, or you can use any other method as well for the homogeneous one. Fine. I hope you got this point, that how the homogeneous is working and how we are separating the mixture. Okay, now if I ask you one question here, that how this salt or the sugar is getting dissolved in the water, that after adding it we are not able to find it out, that whether the salt it is there or the sugar. So what's the reason for that? Do you ever realize this thing? Okay, so here's the answer, student, that what happened now. Okay, I'll just explain it here. So if it is a, okay, I'll just draw some good drawing. Okay, fine. So as we can see here, that if it is a beaker, okay, and beaker or any other utensil, so in that beaker I'm taking some water. So student, what happened, that water is present over here. So this water, so the particles of the water are having space between them. So when there is a space between the particles of the water, so what will happen, student? When you add the salt or any sugar into it, so the salt particles, when you start stirring it, so what will happen, that the salt particle will occupy the space which is present in them. So when it is occupying that space, so what will happen, student? That means they are mixing up with the water, because they are occupying their space between the particles of the water. That's how, students, salt and sugar solution are called as the homogeneous mixture, because we are not able to find out that whether which type of substance we have added it. And that's how, student, when the evaporation is done, so what happened, that the water is going to be evaporated and the salt will left behind. So that's how this is the homogeneous mixture, in which uniformity is there. Why? Because the space is there between the particles and those spaces are filling up by the salt. That's why they follow the uniformity, and that's how, student, we call them as the homogeneous mixture. Fine. Now we are going to talk about the heterogeneous mixture. So what is the heterogeneous mixture, students? As we can see here, so okay, if you remember that in the last session we have seen that the person in a glass, he was adding something blue color of substance and it was not soluble in that, not soluble in the water. Exactly. So that's a, student, heterogeneous mixture, we can say that when we add something into the water and it is not going to be soluble, or we can say that some part of it is going to be soluble but other part will remain insoluble in nature. And that's how we can see that yes, we are able to see that what is present in it. So that's how we call it as the heterogeneous mixture. And that is why, student, we see the non-uniformity in this. So you can see here that I have put one of the picture here, and you can see that here it is a sand, okay, and the water is here. So can you imagine that, like, why I have taken this example? So what happens, student, like if I take example, so if there is a water in a beaker, there is a water, okay, and if you are adding sand into it, okay, so what happens, student, when you add the sand into the water and if you wait for some time and you will not disturb the water, so what you will observe, that the sand particles are going to be settled down at the bottom of the water. Why, students? Because the sand particles are so big that they are not able to mix up with the water. Exactly, because they are that much big that they are not able to occupy the space between the particles of the water. That's why it is not soluble in water, as we have seen soluble and non-soluble thing. So in that condition, we are able to find out that yes, sand is present in the water by looking at the mixture. So such type of mixture in which we are able to find it out that what type of the substance we have added. So that type of mixtures are called as the heterogeneous mixture. Fine. So one is the sand and water, and another example also we of the chalk plus water. So what happened, like when you add the chalk into the water, so yes, water converts its color to the white, but when you observe it very carefully after some time, so what you will find out that some of the part of the chalk has been settled down at the bottom of the water. So when it has been done, so we call this process as the sedimentation process. Okay, sedimentation. And then student, we can separate them out as well, like when we have to separate out sand and water, so what we can do is that we can do the filtration process, because by using the filtration process, we can separate them out. So in the filter paper, sand will remain and the water is left, water is going to be flow down with the help of the funnel. So that's how student, we can separate out them as well. So what we have observed, or what we have discussed about the homogeneous and the heterogeneous mixture, that yes, in both of the condition we are able to separate out the substances, but it's just that in the homogeneous we are not able to find out that which type of substance we have dissolved, but in the heterogeneous we are able to find it out. For example, sand in water, chalk in water. Exactly, students. So that's how you can see by mixing some of the things, and if you are able to find it out, so then you will can differentiate that which is the homogeneous and which is the heterogeneous mixture. Okay, I hope you got this point, that what is the homogeneous and heterogeneous. And that is why student, when the salt and the sugar is occupying the space, that is why they are getting the uniformity, that the substance are particularly arranged. But in the heterogeneous, as you can see, that water is present in the above layer and the sand is settling at the down. So you can see obviously that there is no arrangement of the substances properly. That's how student, we can see that the mixture are of the two type, homogeneous and the heterogeneous. Homogeneous mixture follows the uniformity, whereas heterogeneous mixture do not follow the uniformity. Fine. Okay, so we have discussed about the mixture as well. Now we have to discuss that what's the difference between the mixture and the compound. So students, if you remember from the last time, like from the last session, we have discussed something about the compounds. So in the compounds, what we have seen, that the compounds, they are the mixture. They are also a kind of mixture, but what's the difference is they are the mixture of elements. But if we talk about the mixture only, so we can see here, student, these are the mixture of different substances. Substances are different. That is, compounds are substances which can be formed by chemically combining two or more elements, and they are present in a fixed ratio. Elements are present in a fixed ratio. For example, H2O, CO2, that means if there is the 2 hydrogen, so it will remain 2, and if it is having 1 oxygen, so it will remain 1 oxygen. So that's a student, in the compounds, mixture of the element, that the elements combine together by chemically bond, by the formation of the chemical bond, and we can see that they are having the fixed ratio. So such type of group of the elements, we call them as the compounds. But if we talk about the mixtures, so mixtures are the, you can say it is the substance in which the 2 or 3 substances are adding together, and it's like that it is not having some fixed proportion, no fixed proportion. For example, student, if I take the example of salt water only, so when you are taking water, so it's not like that how much salt you are going to add it in it. You can add 1 spoon, you can either add 2 spoon, and if you increase the amount of the water, so that you can add more and more into it. Exactly. So there is no such fixed proportion that how much you are getting, like how much you are adding into it. So that's how student, mixtures are those type of the substances in which you are adding 2 or more substance, and they are it's just that you are adding them physically. But in the compound, student, what happened, that the elements are combining together with the help of a chemical bond. Exactly, that if we take, so here we can see that physical addition is there, and in this case that the H2O, CO2, they all are chemically combined. Fine, students. So that is the compounds, and that is the mixture, that in the compounds, elements are combined with each other with the help of the chemical bond, and they are present into the fixed ratio. So whatever the condition will be, that ratio is not going to be changed. But in the case of the mixture, that the substance are added up physically, that we people add them according to our need or according to the need of the solution. And that's how student, they are not having any fixed proportion, and we can change it according to our wish, that whether we want to one spoon of salt or 2 spoon of salt. For example, student, that whenever your mother prepared the tea, so what happened, that if you're having grandfather, grandmother, your father, mother, and these all are the elders in your house, so what happened, like someone likes two spoon of sugar in the tea, someone likes one, or someone like half. So that's how it's depending upon our wish. But if we talk about H2 or CO2, so it's not like that, no, that we want 3 hydrogen, we want 4 hydrogen. No, if it is 2, so it is going to be 2 only. But in the mixture, it's it depending on our wish, that how much we want to add it. So that's how, student, in the mixture, it is not the fixed proportion, but in the compound there is a fixed proportion, and they are chemically combined. But in the mixture, they are physically combined. That's why we are able to separate them out till some level. Fine. For example, sugar solution, salt solution, and even though you can take any sand and water, like we have already discussed all such things. So that's how, student, we are able to separate them out. Fine. So what we have discussed about the mixture, homogeneous mixture, heterogeneous mixture, difference between the mixture and compound. So we have discussed all such thing. Now there is one question, that difference between the homogeneous mixture and the heterogeneous mixture. So what's the difference between these two? So difference, if we can see here, so homogeneous mixture, it has a uniform composition, exactly as we have seen salt water as sugar water. It has non-uniform composition. Exactly, we have already seen it has only one phase. Like, why they are telling that they have one phase? For example, again, student, if we take the same example, salt and water, when you are adding the salt into the water, so what happened now, that we are not able to find out the salt, because salt has been dissolved into that. So exactly what we are looking at, that it is having only the liquid phase. That means they are talking about the state, that whether it is having only one state. So that's how in the homogeneous mixture we are having only one phase. But if we talk about heterogeneous, there will be 2 or more phases. Again, sand and water. So what happens? Sand is settling down at the bottom, and sand is what? Solid, and the water is what? Liquid. So we are able to see 2 phases in that. So that's how in the homogeneous there will be only one phase, but in the heterogeneous there will be 2 or more phases as well. It can't be separated out physically. Obviously, when we have added the salt into the water or sugar into the water, so we can't separate it out by using our hand. Exactly. But in that case, in the heterogeneous, we are able to separate them out physically. For example, student, that the sand is having some small pebbles or stones also. So that stones we are able to separate out by using our hand. Exactly. So that's how homogeneous are not separated out physically, but heterogeneous are be separated out physically as well. And homo means same. Yeah, at that time also I was trying to say this thing, that homo means same and hetero means different. That is why in the heterogeneous mixture we are finding out different phases, but in the homogeneous we just find out only one phase after the mixing up of the substance. Okay. So student, these are the differences between the homogeneous mixture and the heterogeneous mixture. And what you can also do is you can add up the examples. For homogeneous, salt, sugar solution. For heterogeneous, sand and chalk solution. Exactly. So I hope you will understand that why we are calling it as one phase and why we are calling it as the 2 or more phases. Okay. So it's just that, student, again, if we see that salt solution is there. So when you are adding the salt and you are mixing it up, so we are not able to find out where the salt has been gone. So that's how we are just looking that, okay, there is only liquid, that is the water. That means it is having only one phase. But if we see the sand water, so in the sand water, we are able to see the sand, which is the solid, and we are able to see the water as well. So we are able, like at that point, we are able to see the 2 phases. Exactly. So that's how, student, there is only one phase, and in that we are having 2 or more phases. So this is the difference between the homogeneous and the heterogeneous mixture. Fine. Okay. Oh, that means we have done with the topics of today's session as well. So now what you have to do is you have to watch this session carefully. And if any question, any query comes to your mind, what you have to do is you can post your question over the public or the private forum of Ask IITians. And that's how you will get your answer from the expert side. And just try to find out different type of mixtures in your surrounding. and figure them out whether they are homogeneous or heterogeneous. Try to find out some more examples of compounds and elements. Okay, so till then, students, thank you for watching this session and study more. And we'll cover up the other part of this session of this chapter in the next session. Okay, thank you.